Hello everyone and welcome to my channel. In this video, I'm going to be showing you how to build a full Palo Alto site-to-site IPSec VPN using IKE version 1 between two remote offices. By the end of this lab, host in site 1 and host in site 2 will be able to communicate securely across untrusted networks using an encrypted tunnel. My name is Travis Johnson. I am a network security engineer focused on Palo Alto firewalls, enterprise security operations, and real-world lab simulations aligned in production environments. I specialize in building and troubleshooting firewall solutions across enterprise environments. So everything you see here is aligned to real-world implementations, not just theory. So in this walkthrough, in this lab, I'll walk you through the topology, how IPSec VPNs work at a high level, the full configuration on both firewalls, routing and security policy, and how to validate and troubleshoot the tunnel. So let's jump in. So as you can see from my lab, we have two Palo Alto firewalls. We're running version 11.2. We have two remote hosts, two Cisco switches, and a Cisco ISP router that will allow us to connect our networks. So the first thing we are going to do, step one, is we are going to, I've already fired the firewalls up. So again, we're going to go over these 5 things, cover the topology, the core components, set up the firewalls, fourth, the routing and security policy, and finally, validating and troubleshooting. So on the left side, you'll see, Site 1 uses the inside subnet of 192.168.101.0/24. The inside firewall interface is going to be 192.168.101.254, and the outside interface is going to be 20.1.1.1. On the right side, I have Site 2. Site 2 uses the inside subnet of 192.168.102.0/24. The inside firewall interface is going to be 192.168.102.254. And the outside interface is going to be 30.1.1.1. In the middle, I have an ISP router simulating the internet and a transport network. The ISP facing next hop site is 20.1.1.254, and for site 2 it's 30.1.1.254. The goal is simple: traffic from 192.168.101 network should securely reach 192.168.102.0 and vice versa through an IPSec tunnel. So before we configure anything, let's simplify the moving parts. Palo Alto site-to-site VPN has 4 major building blocks. One, the IKE Crypto Profile. This defines how phase 1 negotiations work, things like encryption, authentication, Diffie-Hellman group, and lifetime. 2, the IPSec Crypto Profile. This defines how the actual data tunnel is protected in phase 2. 3, the tunnel interface. This is the logical interface that represents the VPN on the firewall. And 4, the IKE Gateway plus IPSec Tunnel. The IKE Gateway defines the peer relationship. The IPSec Tunnel defines everything together. Once that's done, we still need routing and security policy because the tunnel existing is not enough by itself. So before building a VPN, make sure both firewalls, we're going to make sure both firewalls have basic connectivity. That means inside-outside interfaces configured, security zones created, virtual routers configured, default routes pointing to the ISP network, and hosts able to get DHCP addresses because we're going to use DHCP for our labs. So let's begin with the basics. Step 1 is we're going to configure basic networking we're going to configure our basic networking, our basic layer 3 connectivity. So 1.1, guys, as you can see, 1.1 is going to be our outside zone, so it's going to be layer 3. Connect this to a default virtual router. We're going to create a new zone, and we're just going to simply name it outside. Okay. We're going to add our IP address to it, which is going to be our outside interface. So this is going to be 20.1.1 right here. So interface is going to be 20.1.1.1/24. And that's all we should need. But I'm going to add a management profile to this interface for troubleshooting purposes, and it's just to allow ping. Okay. So click OK. Click OK there. Now let's configure interface number 2. So this is, first one was outside, this is going to be inside. Layer 3. Same virtual router. Going to be the default router, and the zone is going to be inside. Okay. IP address, according to our topology, is going to be 192.168.101. And actually, not 101, I'm sorry, 192.168.101.254. Excuse me. So it's going to be 192.168.101.254/24. And that's going to be our inside interface right here. 254. 192.162.101.254. Okay. And we're going to add a management profile so that we can reach it from our host. Add management, so we can reach this and manage our firewall from our internal host. So I'm going to click OK. All right. So next we're going to go over to our virtual router, where we need to add a default route. This default route will allow us, essentially, it tells any internal default route. In this way, the 0.0.0/0, you guys are familiar with routing, quad zeros just represent any network. So when you want to tell the internal router to route traffic from one source to any destination, quad zeros represent any destination. And that's going to be okay. And that's going to be, we're going to create this route connected to this interface. So traffic is going to, this is going to be our egress interface, 1.1, where traffic is going out. Egress out, ingress in. So traffic is going to be leaving, exiting this interface. So we're going to select 1.1, and then next hop is going to be this router interface. So it's going to be 20.1.1.254. It's going to be our next hop for our inside network. So it's 20.1.1.254. It's going to be our next hop router. Click OK. Okay. Next thing we need to do is create a policy, and we're just going to create a broad rule. Allow all rule. And what what this is going to allow is going to allow any source to any destination, any application, any service category or URL category, allow, log at the end of session. Okay, so let's go back and double check. Interfaces are configured, virtual router configured, policy configured. Now click commit. And what this does is this guys just sets up our basic functionality for the firewall as it relates to the networking, the basic networking portion. So let's jump over to our second firewall and do the same thing. So remember, 1.1 is our outside interface, okay? And 1.2 is always going to be inside. So 1.1 is going to be on this side. On site 1, it was 20.1 network. On this side, it's going to be 30.1. So this is going to be outside. Layer 3, same thing. Default virtual router, zone. It's going to be outside, okay? Remember, since it's the outside, it's going to be a 30 network. So it's going to be 30.1.1.1/24, right? And remember, the next hop router is going to be ending. It's going to be 30.1.1.254. So we're going to add ping, a management profile to this, which will allow us to ping that interface just for troubleshooting purposes. Okay. And double check our settings, outside. Okay, click OK. And let's configure inside. So this is going to be our inside interface. Select layer 3. Default. Create new zone. And this is going to be inside. Okay. IP address on this side is going to be the 192.168.102.0 subnet. So let's create that. 192.168.102. I believe it's 254. Yep. 254/24. Now I'm going to hop over real quick and just to verify. That is, yeah, okay. That's 101.254. This will be 102.254. Okay. Let's add some management to this. Add a management profile to this so that we can ping that interface. And we can log into the firewall via the web GUI or SSH. So click OK. Double check our settings. 102.254. Config inside. Click OK. And now we're going to configure our policy. That's going to allow traffic. So allow all, any source, any destination, any application, any service URL category, service or URL. So our category, allow, and log a session. Okay. Let's jump back over here to the virtual router, where we need to add a static route. So we're going to add our default route, which tells inside traffic, allows inside traffic to any network. Because this is where we could specify network, but for purposes lab, we want to do any network. Again, outside interface is 1.1. The next hop is 254. So it's the next hop when it egresses this interface 1.1, it's going to hit 254. So the address is going to be 30.1.1.254. Which is our next hop router. Click OK. Click OK again. Click Commit. Okay. Alright guys, so now that our basic networking is set up, we've gotten that out of the way. Oh, I forgot one thing. Let's jump over here. We're also going to create a DHCP server. And this DHCP server will allocate IP addresses to the host in these subnets. Okay. Let's go here. DHCP. Click add. Interface. So the DHCP server interface is going to be 1.2 because from this interface, the IP addresses within the pool will be allocated to whatever host are in this subnet. Okay. So we're going to do interface 1.2, where the IP addresses will be allocated from. And what's our subnet, guys? 192.168.101.0/24. So we're going to say anything within that subnet you can allocate. And here's where you could reserve different addresses or whatnot. But just again, for the sake of this lab and the purpose of demonstration, we'll just use the entire 24/24 subnet. Also, don't forget you need to define your gateway. So it's 192.168.101. The gateway is going to be this interface address, right? Because that's the gateway out. So it's going to be 254, 101.254. And our subnet mask is 255.255.255.0. Okay. Let's click OK. You can see our pool, and we can see our gateway. So we'll wait for that, and we'll jump over to the other firewall. And we'll go ahead and do the same thing. So again, internal interface is 1.2. The pool is 192.168.102.0/24. Gateway is going to be 192.168.102.254. Subnet mask 255.255.255.0. Click OK. Let's see if that's processed yet. Wow, what's going on? Let's click commit here. Looks like the firewall might be hung here, guys. Not sure why. Firewall 2 is up and good to go. So I'm going to stop this one. Restart it. And hopefully it'll boot back up correctly. Just waiting for the firewall to boot back up. And let's see. Something interesting we can do is we can actually begin, while we wait for Firewall 1 to boot back up, we can go ahead and configure Firewall 2. So step 1 is we're going to start on site 2. The first thing I'm going to do is create our IKE profile. Okay, I'll create our actually in this lab I'm going to skip the I'm going to skip both the IKE Crypto Profile and the IPSec Crypto Profile because I'm just going to use the default profiles. So instead of going through here and changing the groups and overcomplicating this video, I'm just going to use the default profiles because those will work. Those will work just fine. So what I'm going to do is let me hop back over to interfaces, tunnel, and let's create our tunnel interface first. Let's create that. Let's see how it's doing. Booting up. What we got going on? Here we go. There we go. He's getting there, guys. And just like in the real world, you adjust, you adapt, and you overcome. So this is going to be comment. This is going to be site. This is going to be site 2 tunnel. We're going to add this to our virtual router. And this is going to be, we're going to create a new zone for this traffic. And it's going to be VPN zone. Okay. Click OK. Click OK. Let's log back into router 1. And yeah, guys, I kind of wrote this script so that we go through the different profiles, but I don't want to overcomplicate this lab, and it's not necessary. We're going to just use the default IPSec and IKE Crypto Profiles. Just make things a little simpler. So let's wait to see how IKEv1's coming along. And we'll start by creating a tunnel here. So we'll jump over here, create our tunnel. Tunnel 1. Tunnels on both sides have to match when you're configuring these tunnels. This tunnel number has to match on both sides. If you notice, that's going to be tunnel 1. This is tunnel 1. Tunnel has to match. This is site 1 tunnel. I'm going to do our virtual router, just as we just saw in the last on our second firewall. VPN zone. With these tunnels, we don't need to create IP addresses because the connectivity within the tunnel is from Palo to Palo. So if it were, and there's other varying reasons too, but depending on what modes are selected or if traffic is natted or that sort of thing. But for simplicity and sake of this lab, and just to get the tunnel up and work functioning, we don't have to create. We don't have to define IP addresses. Okay. So that's our tunnel. Next, I'm going to go over to. Now we're going to create our IKE Gateway. So we're going to click Add. This defines how site 1 identifies and reaches the IKE Gateway. So I'm gonna take a quick step back just to take it as a teaching moment. When we create a tunnel, this is how I place in the virtual router that already handles routing for this firewall. Again, you can optionally assign an IP address to a tunnel interface in some designs, but for this type of route-based lab, the key thing is the interface itself. Okay, so I just wanted to make sure I clarified that. So let's jump over to our IKE Gateway. Let's define this. So now the IKE Gateway, this defines how Site 1 identifies and reaches Site 2. So imagine this as like a conversation between you and your friend, and you're trying to figure out where you're having dinner at or meeting up at, and this is how you exchange, essentially, how you exchange where you're going to be and what time you're going to be there. So what this version does, what this part of the process does, creating this IKE Gateway, is it exchanges keys, so that first it establishes that you're on, you have the same keys on each side before the tunnel is established. So I'm going to name this Site 1 Gateway. Because it's an IKE version 1 configuration, we're going to do IKEv1 only. Out of interface, our tunnel is going to be leaving interface 1.1, which is our outside interface. Okay, so it's going to be 1.1. Right, our local IP address is going to be our external IP of 20.1.1. Our peer address is going to be reaching out to 30.1.1. So 30.1.1.1. Pre-shared key is going to be whatever password you select. Okay, and there's no need here for local IDs, which is just essentially duplicate or redundant information for local and peer addresses. So we can leave this as none, but if you wanted to, depending on if there was a third-party vendor like Checkpoint or Cisco on the other end, you could define these parameters, key ID, FQDN, or whatever, and so that the firewall matches on both sides. So that's our gateway. Essentially, Site 1 is basically saying, I'm 20.1.1.1, and I want to build a secure tunnel to 30.1.1.1, and here's the crypto policy and shared secret that I'll use. Okay. If we went to advanced options, we get a little more granular. Enable passive mode is essentially prevents the tunnel from being the initiator. So if I enabled passive mode, tunnel traffic couldn't be initiated from this side, only from site number 2. So this would be passive. So this would sit in passive mode, and it would wait. Instead of initiating a conversation, it would only wait to be spoken to before it responded. So enable NAT traversal is for when you're natting traffic, external traffic. This allows that traffic, the firewall, to process that traffic without being confused by the NAT addresses. Exchange mode is how IKE is going to exchange the keys. So main mode is the most secure mode. Main mode, imagine two strangers meeting. Imagine main mode is a formal introduction. So main mode would be if you didn't know someone, you walk up to them and you introduce yourself properly and slowly, right? Hey, my name is John. Pleased to meet you. You shook their hand. You looked them square in the eyes. Auto mode is it doesn't matter if you're meeting someone. It doesn't matter if they say hi or not. You're fine either way. Aggressive mode is, hey John, how you doing? I'm out, and you keep walking. So it's faster. Auto and main aren't as secure as main, but again, for the sake of this lab, I'm going to leave it on auto. And going back to our crypto profile, which you'll see here, which we could have defined there, we're just going to select the default. Okay, click OK. We did configure our DHCP server. Yes. And now we're going to create the IPSec Tunnel object. Okay. So the name is going to be Site 1 to Site 2 VPN. Tunnel interface. Tunnel 1. We're going to select Site 1 Gateway that we created earlier. IPSec Profile. We're just going to use the default profile. We could have created one, specified one, or defined one here, but we didn't because, again, for the sake of this lab, and the defaults are fairly secure as well, so you don't really have to. If you click Show Advanced Options, you go into another set of features, that allow you to tighten, for example, IPSec mode, tunnel. Transport mode is a faster mode. It's less secure than tunnel mode. So tunnel mode is making sure that everything is more secure, where transport mode kind of functions in a little more loose fashion. Okay, so we're not going to select any of those options. Proxy IDs we don't need because when it's a Palo termination point to a Palo termination point, so if you're creating a tunnel between two Palo Alto firewalls, proxy IDs aren't necessary, but if it's Palo to Cisco, Palo to Azure, Palo to anyone else, proxy IDs come in handy because this is where you can define IP addresses. So if we're going from Palo to Azure, this is where you want to assign. Your proxy ID. So you could do quad zeros just as we did earlier. Specify your local address, your remote address, and so forth. So, but we're going to click OK here. Okay. Static routes we've already completed, but let's double check. Virtual routers, default. We have one static route, so now we're going to need to add another route. This is where I need to tell Site 1 how to reach the remote LAN. So we're going to do Site 1 to Site 2 route. Our destination is going to be that subnet of 192.168. That's the internal subnet. So our destination is this internal subnet. Okay. 192.168.102.0/24. We're going to that whole network. Okay. Interface. Specify the tunnel. And the next hop for this tunnel interface is going to be none. We've already specified the next hop in the default route, but for tunnel, we don't need to specify. So click OK. Click OK. That's a critical part because without the route, the firewall won't know to send Site 2 traffic into the VPN tunnel. So that's why this part is so critical, because if you don't add that part, the firewall won't know how to send Site 2 traffic into the tunnel. So we've already created our security policy, which is just a wide open policy. It's allow all policy. So now what we're going to do is going to click OK. Click Commit. And now we're going to mirror the config on the other side. So I'm going to create that whole process again. So interfaces are configured. Yep. Let's go to our zones. Zones are configured. Virtual routers. And I like to do it like this. I'll do it a little quicker on this side, guys, because just for the sake of it. Let's do site 2 to site 1 route. Subnet is 192.168.101.0/24. Excuse me. Interface. Oops. See what I did wrong there? It's not interface 1.1. It's this tunnel interface. So select tunnel 1. 2.168.101.0/24. No next hop. Click OK. Okay. So our routing is done. Now we'll create our IKE. This is going to be, I like to keep the naming conventions the same. Site 1. So it's going to be site 2 gateway. IKE only, IKE1 only. Interface is going to be external interface, the gateway. 30.1. Peer address is going to be 20.1.1.1. Don't need to specify the CIDR. No, okay, yeah we do. Yeah we do. Pre-shared key is going to be password, advanced options. Exchange mode is auto on both sides, because again, guys, it's the configuration is just mirrored on both sides. Crypto profile is default. Click OK. Now we're going to create our tunnel. Click add. And again, naming convention is important. Site 1 to site 2. We're going to do S2 to S1. Tunnel interface is tunnel 1. IKE gateway, site 2 gateway. Proxy IDs no need. Crypto profile default. Click OK. We're going to click. Let's verify that we did. Yep, okay. Wasn't sure, couldn't remember. Click commit. I want to check to see, make sure I configured the routes correctly. Now, mind you guys, these devices are DHCP devices, so we're going to open this one up and see if the firewall has allocated IP addresses to these devices. So, IPA, here's our IP address, right? That's our subnet 101.0. So it's giving it a 2 address. And this one has IPA, a 102.2 address. So 101.2, 102.2. Great. Okay. Alright, so that's about done. This one is done. You can see right now that our tunnel is down. Right? This red indicates that the tunnel is down. The status of the interface is good to go. Jump over here. Same thing. Status of the interface is good to go. Tunnel information. Okay, got some basics in there. And it won't show anything until we generate some traffic, so I'm pretty sure. Let's ping. So we're going to ping 192.168.102.2. Let's see what we get. All right, we have some pings. So let's see if we can ping the other side. Ping 192.168.101.2. And we can ping from both sides. Great, outstanding. So let's go to our logs. And you can see ping is allowed from source destination 101.2. Yep, VPN, hitting the VPN zone. If you go to system logs, which I already have a filter in for subtype equals VPN, you can see where site 1, the key was negotiated. You know, if you want to look at VPN, guys, if you want to look at your VPN key exchange, one of the ways to do it, just go to system logs, filter on VPN, and you can see essentially the different phases of the key exchange and the tunnel creation. So you can see that here. So if we refresh this page, see that the tunnel info turns from red to green. We click tunnel info, site 1 and site 2 VPN, local, peer. You can see packets exchange, packets encapsulated, decapsulated, so forth and so on. You go to IKE info, mode, it'll tell you main mode, which as I described earlier is the most secure of the 3 modes of main, aggressive, and auto. This is the role is the initiator. If we go here, see the role is the responder. Right. So if we were to, going back to the passive mode configuration, if we were to enable passive mode, only one of these, they both couldn't be both of these tunnels, only one side of the tunnel could be a responder or an initiator, right? The other one would be passive. So just like in life, if you know, the passive side would just be quiet until spoken to. So anyway, so now we validated it. Let's do some additional validation. So let's go to network, site tunnels, and gateway is shown established. I wonder, we jump over here. Our interfaces won't show us anything, but that'd be neat if we had a VPN widget. So we can go here, and again, pretty much all the information we need is here. Show routes, so we can see our routes, our default route, right, from our internal network, right, to any destination. You know, this is our internal stuff, and then you see this one route, the tunnel. Tunnel traffic is the only traffic that's going towards the remote site at 102. The remote subnet. So you can see that there. Forwarding tables, static routes. We could also, if we wanted to, let's do this. We can open up a browser within our host. And so the web server address to this host is going to be its IP address. So we're going to do http://192.168.102.2. That's the IP address of this device. And we can reach our Apache default page, our Apache web server. So there you have it. Everything's working as it should. So just do a quick recap. Building the Palo Alto IPSec site-to-site VPN tunnel comes down to this. Build matching IKE Crypto Profiles. Build matching IPSec matching IKE Crypto Profiles, IPSec Crypto Profiles. Create the tunnel interface. Create your gateway. Create your tunnel. Add routes for the remote LAN. Allow the traffic with security policy. And validate both tunnel status and live traffic. If you understand those pieces, you understand the architecture. So this is the kind of lab that maps directly to real firewall engineering work, especially in enterprise environments that still maintain site-to-site VPN connectivity between branch offices, data centers, and remote networks. If this video helps you, subscribe for more Palo Alto Labs, practical security engineering walkthroughs, and real-world troubleshooting content. In the next video, we can build the same topology using IKE version 2 or add NAT exemption and verification. Thanks for your time, and see you in the next video.